Dear students, today we will learn logarithmic differentiation. Logarithms, you already know what is logarithm and some of the properties of logarithms. Let us just briefly discuss them. We say log b to the base a is equal to x, provided a raised to x is equal to b. Log b to the base a is equal to x if a power x is equal to b. Then properties, that is log mn is equal to log m plus log n. Okay. Here I have not written the base, which means you have to understand that the same base. Okay. Or if I have log mn to the base a, it is to be log m to the base a plus log n to the base a. Then log m by n to the base a is equal to log m to the base a minus log n to the base a. Then log m raised to n to the base a is equal to n into log m to the base. Then log b to the base a can be written as log b to the base c divided by log a to the base. Okay. So these are the properties we have learned in logarithms. Now let us see what is logarithmic differentiation, or how these logarithms can be used while differentiating a function. Okay. See, suppose if I have a problem, let us say sin x power cos x. Sin x to the power cos x. I would like to, the question is find the derivative of this function, differentiate this with respect to x. If that is a question, then how do we solve this? Can we treat this as it is in the form a power x? The answer is no, because it will be an exponential function. It will be of the form a power x, means this base should be a constant and the power should be a function. Base is a constant and the power is a function. Now base is a function, power is also a function. Power is okay, but this base is should not be a function. So you cannot compare this with a power x. Okay. Then the next question is, can I compare this with x power n? Because we already know that the derivative of x power n is n into x power n minus 1. Then can we write the derivative of this as cos x into sin x to the power cos x minus 1 into the derivative of sin x, or the derivative of cos x, etc. Is it possible to see that it is in this form x power n? The answer is no. Because in x power n, what do we have? The base is x. The base must be a function. That's okay, no problem here. And the power should be n. N is a real number. Here the power is cos x, which is a variable, which is a function. So you cannot compare this with the x power n. Neither you can compare with the a power x, nor you can compare with the x power n. So as of now, we don't know how to differentiate this function. Okay. Then does it mean that this function is not differentiable? No. The answer is no. We can still differentiate it by using logarithms. I'll explain how. So as always, we shall call this as y. And y is equal to this. Y is equal to sin x to the power cos x. So if I call this as y, we are asked to find the derivative, which means we want dy by dx. Okay. So directly I cannot differentiate, as I have explained already, because it's neither in the form x power n nor in the form a power x. So what else can we do? We shall take log here, applying log on both sides, or taking log on both sides. That will give you log y is equal to log sin x to the power cos x. Log sin x to the power cos x. Okay. So log y is equal to log sin x to the power cos x. This is of the form log m power n. Log m power n can be written as n log m. Log m power n is equal to n log m. So you get cos x into log sin x. Cos x into log sin x. Now you can differentiate it. See, now it is a product of two functions. So cos x is one function here, log sin x is another function. Both are differentiable. We can easily differentiate. Now differentiate this function with respect to x. Differentiating with respect to x. Okay. Log y. Derivative of log y. Derivative of log x, as you know, which is 1 by x. So derivative of log y is 1 by y into the derivative of y, which is dy by dx, is equal to. On RHS, I am using the product rule of differentiation. First function, which is cos x, into the derivative of the second function, derivative of log sin x. Derivative of log sin x is 1 by sin x into the derivative of sin x. What is the derivative of sin x? Cos x plus. Okay. Next, second function, which is log sin x into the derivative of the first one. What is the derivative of the first function? Derivative of cos x, which is minus sin x. Okay. So now dy by dx is equal to, take this y to RHS. Y into, here cos x into cos x will be cos square x divided by sin x minus sin x into log sin x. Sin x into log sin x. Now dy by dx is equal to y. What is y? Sin x to the power cos x. Sin x to the power cos x into, right, cos square x by sin x minus sin x into log sin x. Sin x into log sin x. Okay, this is dy by dx. In this way, we can find the derivative of this function. Okay. Let me take one more. Suppose if I have, let us say, x plus 2 into x minus 1 divided by x plus 3 into x minus 2 whole power 1 by 4. Differentiate this function with respect to x, if that is the question. Then, see, without using logarithms also you can differentiate it. How? You treat this as x power n. Derivative of x power n is n into x power n minus 1. 1 by 4 into x plus 2 x minus 1 divided by x plus 3 into x minus 2 to the power 1 by 4 minus 1. 1 by 4 minus 1 is minus 3 by 4 into the derivative of this factor x plus 2 into x minus 1 divided by x plus 3 into x minus 2. Right? Again, then to differentiate this, we have to use quotient rule. While using quotient rule, in order to find the derivative of this, we have to use product rule of differentiation. So it will take a lot of steps, a lot of time, okay, a lot of space also, which I don't have here. So in that way, you can differentiate it. But you can differentiate it by using logarithms also. By using logarithms, to simplify this, then the differentiating would be much easier. How I will explain it now. Okay. So we have taken that as y. Y is equal to x plus 2 into x minus 1 divided by x plus 3 into x minus 2 whole power 1 by 4. Now I will take log on both sides. Taking log on both sides, that will give you log y is equal to log of x plus 2 into x minus 1 divided by x plus 3 into x minus 2 whole power 1 by 4. Okay, that's equal to log m power n. Log m power n is equal to n log m, right? So by using that, I can write it as 1 by 4 into log of x plus 2 into x minus 1 divided by x plus 3 into x minus 2. So y is equal to 1 by 4 into, say, you can write this as log m by n. Log m by n is equal to log m minus log n. And further, log m into n can be written as log m plus log n. So after simplification, I can write this as log x plus 2 plus log x minus 1 minus log x plus 3 minus log x minus 2. Okay? So after all the simplification, this is what we did. Now differentiate this. Y dash is equal to 1 by 4 into derivative log x plus 2 is 1 by x plus 2 plus 1 by x minus 1 minus 1 by x plus 3 minus 1 by x minus 2. That's all. That's the answer. Sorry, I made a mistake here. Log y. This is log y. Now differentiate this. Derivative of log y is, what is the derivative of log y? 1 by y into y dash. Right? Derivative of log y is 1 by y into y dash. So y dash is equal to y into y. Find out what is y. This is y. 1 by 4 into x plus 2 into x minus 1 divided by x plus 3 into x minus 2 to the power 1 by 4 into this factor 1 by x plus 2 plus 1 by x minus 1 minus 1 by x plus 3 minus 1 by x minus 2. This is the answer. Okay. So in this way we can easily, by taking log and simplifying it, then if you differentiate we will get the derivative much easily when compared to the original method. Okay. So today in this class we shall discuss problems on logarithmic differentiation. Okay. Write down the question. Find the derivatives of the following functions with respect to x. Or you can differentiate the following functions with respect to x. Differentiate the following functions with respect to x. Differentiate the following functions with respect to x. First, x power x. X power x. Okay? I'll take it as y. Let y is equal to x power x. Taking log on both sides. See, if I don't take log, we cannot directly differentiate it because this is neither in the form x power n nor it is in the form a power x. Neither the base is a variable, neither the base is a constant nor the power is a constant. If the base is constant and the power is a variable, you can write a power x. It is in the form a power x. And if the base is a variable and the power is a constant, then we can say it is in the form x power n. Now here you have base is a variable or the function and the power is also a function. So we cannot use those methods. It's not, you cannot compare this with a power x or x power n. So I will take log on both sides. Then we get log y is equal to log x to the power x. Okay. Then log y is equal to log x power x can be written as x into log x. Log y is equal to x into log x. Okay. Now let us differentiate this. Differentiating with respect to x. When I differentiate this with respect to x, we get 1 by y into dy by dx is equal to x into product I am using x into derivative of log x, which is 1 by x, plus log x into derivative of x, which is 1. X is cancelled. Take this y to RHS, so that will give you dy by dx is equal to y into 1 plus log x. See here I have cancelled this x. So y into 1 plus log x. Therefore dy by dx is equal to y. What is y? X to the power x. X to the power x into 1 plus log x. Okay, this is our derivative. Dy by dx equal to x power x into 1 plus log x. Okay. Let us look at the second question. X to the power cos inverse x. X to the power cos inverse x. I take this as y here. Y is equal to x power cos inverse x. Now taking log on both sides. Or if you just write taking log, it's enough because whatever the operation that we do on any equation, we must do it on both sides of the equation. So if I take log here, we get log of x to the power cos inverse x. Okay. So log y is equal to log m power n. Log m power n can be written as n log m. So that will give you cos inverse x n log m into log x. n. Log m power n is equal to n into log m. Now differentiate it. Differentiating with respect to x. Okay, you write that step here. Should I write that? Okay, right. Differentiating with respect to x. So when I differentiate log y with respect to x, I am getting derivative of log y is 1 by y into dy by dx. That's equal to 1 by y into dy by dx. Here product rule we will use cos inverse x into derivative of log x. First function into derivative of the second. So cos inverse x into derivative of log x. Derivative of log x is 1 by x. Plus log x into second function into derivative of the first function. What is the derivative of cos inverse x? Yes, right. Derivative of cos inverse x is minus 1 by root of 1 minus x square. Okay. Take this y to RHS. We get dy by dx is equal to y into cos inverse x divided by x plus or minus log x divided by root of 1 minus x square. Write down what is y. So dy by dx is equal to y in place of y. What is y? X to the power cos inverse x. X power cos inverse x into cos inverse x divided by x minus log x divided by root of 1 minus x square. X power cos inverse x into cos inverse x by x minus log x by root 1 minus x square. Okay, this is dy by dx. Next, sin x to the power log x. Sin x to the power log x. Okay. Very similar to the earlier problems. Here also we shall take this as y. Y is equal to sin x to the power log x. Okay, sin x to the power log x. Taking log on both sides, that will give you log y is equal to log sin x to the power log x. Then log y is equal to log sin x power log x. This is of the form log m power n. Log m power n is equal to n into log m, which means log x into log m power n, n into log m. Log x into log sin x. Log x into log sin x. Now let us differentiate this. Differentiating with respect to x. That will give you derivative of log y, which is 1 by y into dy by dx is equal to, on RHS we have the product of two functions, log x into log sin x. Let us differentiate that product rule by using product rule. Log x into first function into derivative of the second. Derivative of log sin x is 1 by sin x into cos x, into the derivative of sin x, which is cos x, plus log sin x into now the derivative of log x, which is 1 by x. Okay. So 1 by y into dy by dx is equal to log x into cot x, cos x by sin x, I am writing it as cot x, plus log sin x divided by x. Don't write sin x by x is equal to 1, it is not true. Sin x by x is equal to 1 only when x is approaching 0. Okay. So now transfer y to that side. Dy by dx is equal to y into log x into cot x plus log sin x divided by x. Okay. So dy by dx is equal to y into y is sin x to the power log x. Sin x to the power log x into log x into cot x plus log sin x divided by x. Okay, this is the derivative. Next question. Tan x power cot x plus cot x to the power tan x. Cot x to the power tan x. Okay? Tan x to the power cot x plus cot x to the power tan x. Here, if I directly take log, let us see what happens. If I directly take, okay, then y is equal to this, then the log y is equal to log of tan x to the power cot x plus cot x to the power tan x. If I take like this, then can I use log m power n formula? No. You cannot write this as cot x into log tan x plus tan x into log cot x. That's not correct. So then this is like a log m plus n. What can I do with log m plus n? Can I write it as log m into log n? No. The formula that we have is log mn. Log mn is equal to, we can write this as log m plus log n. But if you have log of m plus n, no further simplification is possible. Log m plus n can only be written as log m plus n. No further simplification is possible. So if I directly take log here, this is what we get. You cannot use this formula. Log m power n, this is equal to n log m. This is correct. But if I have a log of m power n plus p power q, you cannot write this as n log m plus p q log p. This is wrong. Don't do this. Okay, that is it. No further simplification is possible with this. This is incorrect. You cannot do this. Okay. Then what else can we do? Then how can I differentiate? Okay, let me explain you how to differentiate. So as always, we will call this as y. Now, in order to differentiate it, what we do is, we will treat these two as two separate problems. Treat this as u, and of course this as b. Let y be equal to u plus p. We'll write it like this. Let y is equal to u plus p. Then what is dy by dx? dy by dx is equal to du by dx plus dv by dx. U and v are the sum of two functions. So that y is a function of y is the sum of two functions u and v. Then dy by dx is the sum of their derivatives, right? Du by dx plus dv by dx. So now, where u is equal to, treat this as u, tan x to the power cot x, and v as cot x to the power tan x. Okay? U is equal to tan x power cot x and v is equal to cot x to the power tan x. So now you treat these two as two separate problems, and you know how to differentiate this, right? Taking log and then differentiating, you know. Similarly, you know how to differentiate this and differentiate it separately. And in the last step, when you add, because dy by dx we want, which can be written as du by dx plus dv by dx. Okay. So first I will take u. U is equal to tan x to the power cot x. Tan x to the power cot x. Okay, taking log on both sides, that will give you log u is equal to log tan x to the power cot x. I can, after simplification, I can write it as cot x into log tan x. I don't have enough space here to write those steps in detail, so I think you can understand now. Now differentiating this with respect to x, derivative of log u is 1 by u into du by dx is equal to, here I am using product rule, cot x into derivative of log tan x is 1 by tan x into secant square x, into the derivative of tan x which is secant square x, plus log tan x into the derivative of cot x. Derivative of cot x is minus cosecant square x. Okay, so that means du by dx is equal to u into, what is u? That right, u is tan x to the power cot x, tan x to the power cot x into this function. Cot x by tan x into, or directly write cot square x into secant square x. Okay? Tan x and take it in the numerator, cot x into cot x is cot square x into secant square x minus cosecant square x into log tan x. Okay, this what we have got here is du by dx. We want dv by dx also, because dy by dx is equal to du by dx plus dv by dx. Let us take v. What is v? V is equal to cot x to the power tan x. Cot x to the power tan x. Take log on both sides. Log v is equal to tan x into log cot x. Tan x into log cot x. Now differentiate it. 1 by v into dv by dx is equal to tan x into derivative of log cot x is 1 by cot x into minus cosecant square x plus log cot x into the derivative of tan x, which is secant square x. Okay, so dv by dx is equal to v into what is v? Cot x to the power tan x, cot x to the power tan x into this factor. This cot x I am taking numerator, become tan x 1, it will become tan x. Already tan x is there, it will be tan square x. So minus tan square x into cosecant square x plus secant square x into log cot x. Secant square x into log cot x. Okay, this is dv by dx. We want dy by dx. dy by dx is equal to du by dx plus dv by dx. So add these two. Here I don't have enough space here. So, but you have plenty of space in your notebook. So write the sum of these two, du by dx plus dv by dx. That will give you dy by dx. Next question, x to the power sin inverse x plus sin x to the power x. X to the power sin inverse x plus sin x to the power x. Very similar to the previous problem. I will call this as y. Let y is equal to this. U is equal to x power sin inverse x. And v is equal to sin x to the power x. Whenever you see such functions, one function to the power another function plus another function, its power is one more function, then you treat these two as two separate problems, take them individually and take log, differentiate, get the answer, and finally add those derivatives. Okay. So taking log here will give you log u is equal to sin inverse x into log x. Differentiate it with respect to x. 1 by u into du by dx is equal to sin inverse x into derivative of log x, which is 1 by x, plus log x into derivative of sin inverse x, which is 1 by root 1 minus x square. So du by dx is equal to u into what is u? X to the power sin inverse x into this sin inverse x divided by x plus log x divided by root of 1 minus x square. This is du by dx. Now on the other hand, let us take v. v is equal to sin x to the power x. Taking log will give you log v is equal to log sin x to the power x, which can be written as x into log sin x. Now differentiating with respect to x will give you 1 by v into dv by dx is equal to x into 1 by sin x into cos x plus log sin x. Observe here I am using product rule of differentiation. X first function into derivative of the second. Derivative of log sin x is 1 by sin x into the derivative of sin x. Derivative of sin x is cos x. plus second function which is log sin x into the derivative of x which is 1. So dv by dx is equal to, take this v to RHS. So v into, what is v? Sin x to the power x into this factor. I can write cos x by sin x as cot x. So x cot x plus log sin x. This is dv by dx. We want dy by dx. As you know, dy by dx is equal to du by dx plus dv by dx. That's equal to du by dx is x to the power sin inverse x into sin inverse x by x plus log x by root 1 minus x square plus dv by dx, which is sin x to the power x into x cot x plus log sin x. Okay, this is dy by dx. Next question. X plus 1 by x whole power x plus x to the power 1 plus 1 by x. X plus 1 by x whole power x plus x to the power 1 plus 1 by x. So let y is equal to this. Let u is equal to x plus 1 by x whole power x and b is equal to x to the power 1 plus 1 by x. Okay. So I am taking this first function as u and the second term as b. Now consider this, u is equal to x plus 1 by x whole power x. Taking log on both sides will give you log u is equal to log x plus 1 by x whole power x, which can be written as x into log of x plus 1 by x. Now differentiating this with respect to x will give us 1 by u into du by dx. That's equal to, I am using product rule here, x into derivative of this, which is 1 by, derivative log x is 1 by x. So derivative of this expression is 1 by x plus 1 by x into the derivative of x plus 1 by x. Derivative of x plus 1 by x, derivative of x is 1 plus the derivative of 1 by x. Derivative of 1 by x is minus 1 by x square plus log of x plus 1 by x into the derivative of x, which is 1. Okay, I take LCM here. X square, x is the LCM, x square plus 1 by x. That will come up by root x square here. Here x square minus 1 by x square. This x square, that x square gets cancelled. So du by dx is equal to u into, here you observe x square plus 1 by x. Here x square minus 1 by x square. This x which is in the denominator will come up. So x square, that x square gets cancelled. So after all the simplification, I can write this as x square minus 1 divided by x square plus 1 plus log x plus 1 by x. So du by dx is equal to u into, what is u? X plus 1 by x. X plus 1 by x whole power x into x square minus 1 divided by x square plus 1 plus log x plus 1 by x. This is du by dx. Now dv by dx, b is equal to x to the power 1 plus 1 by x, taking log b is equal to 1 plus 1 by x into log x. Now differentiating with respect to x will give you 1 by v into dv by dx is equal to 1 plus 1 by x into derivative of log x, which is 1 by x, plus log x into the derivative of 1 plus 1 by x, derivative of 1 is 0, derivative of 1 by x is minus 1 by x square. So dv by dx is equal to v into v is x to the power 1 plus 1 by x into, here if I simplify it will become x plus 1 by x, another x is there, so x plus 1 by x square minus log x divided by x square. This is dv by dx. We have du by dx as well as dv by dx. In the last, take the sum of these two. dy by dx is obtained by du by dx plus dv by dx. Okay. Students, with this I will stop this class. We will continue our discussion on logarithmic differentiation in the next class. Thank you.